happening right now? Good morning, everybody. To our last topic up for discussion. Should make sure I have everything open here. Yeah, okay, good. We have talked about percentages in a way that allows us to, in my opinion, cross over very nicely to our last topic, algebraic thinking, variables and equations. Now, because this topic for most of us is fairly familiar, not necessarily to use, but the concept is quite familiar in my experience. Let me just move this slightly down, maybe like that. Okay, so let's talk about variables. Ooh, my computer is very laggy today. That's wonderful. And equations. Ooh, it takes like a second before I actually see what's on the screen. That's not great. I'm going to close the D2L because no one watches that anyway, and it causes a lot of slowdown. Let's see if that helps. Ooh, that was an annoying sound. Okay, let's see if that works. Anyway, variables and equations. So with percentages previously, oh yeah, huge difference. Previously, we looked at, let's say, we don't know some original amount, and it was, let's just randomly say, increased by 10% to get me my new amount, which they give me. Let's suppose it's $2,000, whatever. We then said, let's make a symbol here, and I chose question mark in a box. Just make the question mark a little bit more official. Of my choice, symbol of my choice, because I know that in the translation from all these words to the mathematical language, I would need to reference this original amount because the decimal factor, or whatever you want to call it, is multiplied and applied to this original amount. And there is a number, I just don't know the number. And I need to give this number a temporary name while I'm still in the process of figuring out what it is. That will be called the variable. Now, the word variable, in my opinion, at this low level is a little misleading because it's not something that changes. It's not something that varies at all. Once I have said what it represents, that's what it represents for these basic kind of problems. I just want to figure out now, by analyzing this mathematical sentence, what that mystery number behind the variable is. It can be any symbol, any symbol. So as much fun as it is to draw smiley faces and question marks and maybe stars and whatever, you're welcome to always do that. But people got a little lazy, I guess, and they just use letters that don't come up often, like an X or a Y and stuff like that, instead of a much more creative symbol. I like the symbols instead of the letters, but that's what people end up using. So you can really use anything at all for your variable name. My issue is still the translation. The variable is the link between the original word problem and my translation into the mathematical language. I have to start by saying what it means. Then I can go with an equation involving that variable, and I'll analyze that in a second. Now, we've already seen how we can rewrite these equations, these mathematical sentences, so that they are more helpful to us. Like in this case, I have a multiplication sentence. The fact that these are symbols and more complicated numbers doesn't change what it is. And I can rewrite that to an equivalent division sentence. Little Timmy would have done that uh, since grade these days, maybe 4, but hopefully 3, multiplication and division, ideally. So it just looks different. The numbers that they would use to write these 4 equivalent sentences would be simpler, of course, but it doesn't change that the information is the same. Information is the same. And that's the key. I want to rewrite this equation, pretending it's more difficult perhaps, to a point where I can see how to calculate the variable. But I don't want to lose the meaning of the sentence. Then I've changed the question. So luckily within this mathematical language, within these equations, there are ways uh, to rewrite these equations without losing the meaning. Let's have a look at that. And I'll do that briefly by just referencing the book. Just want to make sure my webcam isn't in front of this. I don't think it is. Let me just double check. No, I'm good. So the balance scale motivates this completely. In the case where I have a mystery quantity with some 3 other blocks, and I have how many on this side? 7. They're in balance, and I get the equation that corresponds to this, x plus 3 equals 7. And of course, logically, it's not a big step to say that if I take 3 blocks off on each side, then everything is still in balance, which says that I can subtract an amount as long as I do it on both sides of the equation, and the resulting equation has the same information. It's the same scale, same thing. And that way I can see what the mystery amount is. It's equivalent to 4 units. So I can subtract, and of course I can do the same thing by adding. Everything's going to stay in balance. So add and subtract on both sides. I'm just looking for my other picture. Adding and subtracting by a quantity or an amount on both sides won't change the balance that I have. Here I have 3x's equal to 6, all in balance. So if I divide both sides by 3, take a third of what I had, a third of what I had, as long as I do it on both sides, everything's going to stay in balance. Telling me that that's a way I can manipulate the equation by dividing or multiplying by the same number on either side, and I don't lose the information. That's summarized, I think, not. Oh, I can't see the bottom here. Hold on. Over here. Following operations won't change the solution, the meaning of the equation. Add, subtract, multiply, divide by the same number on both sides. 0 is a little different, so I don't want to use 0 as that number I use on both sides. As long as I stay away from 0, I can do it as long as I do it on both sides. Okay. So in the case of exercise 16.1, I'm not going to insult your intelligence. We can just look at it. I'm going to subtract 2 on both sides to get x equal to 6. So my goal is always the same. My goal is to rewrite the equation, which is just a sentence in this language, rewrite it to an equivalent sentence, but one that shows me how to calculate the variable's value. For this 2x plus 8, I'm going to divide both sides by 2 and then get x equal to 4. Pretending it's more complicated, I don't know what the value is, and guessing and checking is not going to work in complicated situations. I need to manipulate the look of the equation without changing its meaning. That is the most important thing. People forget that so easily. It's all about the meaning has to stay the same. And within that language, luckily, I have some things I can do. Let's do exercise 16.3. Just so I don't appear too lazy and I actually write stuff down. Now, this is just a little snippet of the larger solution process. Somewhere this equation comes up. I want to just do it systematically. I want to add 1 on both sides, and I can scribble underneath what I'm doing and then rewrite the equation. 3x equal to 15. So it can be a stepwise process. Systematically, I'm getting this variable alone on one side of the equation in order to then see its calculation. Then I'm going to divide by 3 both sides. Many people just choose to write it like this, and that's perfectly fine. X equal to 5. This equation, this equation, this equation, they're all the same in terms of the meaning that they carry. The first one was just a little bit hiding what that x's value actually is. So I'm looking at rephrasing it until I can very easily see what it is. So it's a step up from changing a multiplication sentence to a division sentence, but the result is the same. Okay. So when it comes to equations, I can do those 4 things in any order that I want, as long as I systematically get to a version of the equation that is so simple it just tells me what the variable's value is. And I like to have some fun with it. Especially in high school, you do a lot of these things over and over and over, and you don't really see the point. They don't throw enough sort of word problems and applications into it. Sometimes it's hard, but I like to make a game of it. Can I find the sequence of steps that I can do systematically, getting the variable alone on the left? Make a game of it. Have some fun with it. I tried to convince someone once that yes, it feels a little boring and abstract when it's not connected to a word problem, but you see it as a game. The challenge is, can you figure out what the variable's value is? And he looked at me in all honesty and said, it's not a very fun game. But I didn't have any counter to that reaction. So I suppose it's not very fun, but if you make it fun somehow, then it becomes more enjoyable. Let's see. A very simple word problem, just to again emphasize the procedure I follow through literally any word problem. 2 times a number increased by 1 is 15. That's it. What's the number? Now I know in this simple situation, you can totally guess and check your way through it. But very quickly, the complexity of a word problem is just a little too much for that guess and check strategy to work. It just won't be something that's reliable for very long. I am always going to take a 4-step approach to a word problem. And when I do step 1, I'm doing step 1. I don't worry about a future step. I isolate these steps so they can help me systematically move towards the answer. People are obsessed with the answer. When I do step 1, I don't care about the answer. It's going to come out as a result of this 4-step process. Now I know this one's super simple, so we can very easily verify that we get the right answer. So 2 times a number, I have some mystery number. some information is given about that number. But in order for me to translate that information into the mathematical language, I need to have a variable. Now you can make that variable name anything you want. I'll be super boring and make it an x. Let x represent the mystery number. Mystery number. So for step one, you need to have a full sentence that links the mathematical language and the English language. Full sentence, so that there's no doubt anyone who reads this understands what your variable is, what it means. Now I want to translate the information that 2 times a number, then increased by 1, gives me 15. I still put some English words there, just make it nice. 2 times a number, and when it's a number times a variable, we don't need the multiplication sign in there as well. Some people make their x's like that, and then if you say 2 times x, it looks very, very tricky and confusing, so I don't want to do that. Plus 1, because it says increased by 1, gives me 15. And I've translated, yes, in this case, super simple, I know, but it's not going to change when it gets more complicated. Translated the information that was presented in English into my mathematical language, and I get a mathematical sentence. Now within that sentence, I was a little bit too close on my 4 here. Third step is to then work within that language, and it has its own rules and its own grammar and its own things that you can do to manipulate sentences to find out how can what's the value of this variable, pretending this is much more complicated, right? So I can subtract 1 on both sides. I scribble little hints here to keep track of what I'm doing. Then I'm dividing both sides by 2. So x is equal to 7. That was all step 3. That was not a pretty bracket. I apologize. But I'm just going to leave it there. See what happens. Then my original question was phrased in English. I am going to wrap everything up by saying my answer in the same language. The mystery number is 7. Now, in a larger problem, you get the issue that someone who reads it might not know the details of the methods used in step 2 and 3, but they still want to know the answer. It's just a nice courtesy to everyone who may read this to finish your answer with a concluding sentence in the language of the original question. It's just a good habit to get into. All right, 4 steps. Nothing's going to ever change about that. Now, I'll just show here. I don't want to really obsess about these properties. Somewhere, someone, they decided, let's classify these properties for how I can work with equations and rewrite things and shuffle things around. But they're all obvious if you really think about them. The first one, it just says that if I add or multiply numbers, it doesn't matter if I have this one first, that one first, I can swap them around. Doesn't matter. We all knew that. This is just sort of making it official that it always works for any number. The next one says that if I have 3 things that I have to add up, I can do them pairwise. And it doesn't matter which pair I do first. Multiplication as well. But that's the same with numbers. Do them systematically, right? As long as what I'm doing is the same throughout, addition or multiplication. And the last property is a link between multiplication and addition that you can argue with an easy little diagram that we sort of casually say we multiply the a into the bracket, into the first term in the bracket and into the second term into the bracket. And if you're not familiar with these things, then maybe go brush up some high school math, which is a prerequisite, of course, for this course. But you don't have to remember these names or anything like that. I won't ask it in any sort of test, ever. Just to make it official, it's in the book. If you remember these things, maybe. I don't need to label them to know what to do. So for some reason, I have this equation. Let's just run through that to see. Oh, I have no space. To see, I guess, something more complicated. What I mean by these properties, but you don't ever have to label them. What was my equation here? Exercise 16.5. I'm solving 2 times in brackets x plus 4 equals 7x plus 2. Just made up, I know. But we can get similar things from word problems later on, absolutely. So, now I just have to systematically figure out how I can rewrite this equation until I can see the answer. Well, first, I want to simplify the left side by multiplying the 2 in, so to speak. 2 times the first term in the bracket plus 2 times the second term. The right-hand side stays the same. Now, we're not spending a lot of time practicing this because it is part of your prerequisite coming into the course. But if you have trouble with it, I can definitely give you a resource to practice this and so on. You just have to find the appropriate grade. Now, what I want to do is add and subtract both sides, but I want to group similar things together. I have some terms here that have x's. I have 2 x's on the left. I have 7 x's on the right. Maybe I will subtract 2 x's on both sides because I have more x's on that side. Take 2 x's away on both sides. Then I have 8 left, and I have 5 x's left on the right, and still plus 2. So let's subtract 2 on both sides. Then I have 6 equal to 5x. Personal preference, I like the variable on the left side of my equation, but if this side is equal to that side, then that side is equal to this side. Doesn't change. And then just personal preference. Divide both sides by 5, because this is 5 times a single x, to get x equal to a little fraction. Let's leave it like that. Or because it's a final answer, I can present it as 1 1/5. Or if I like decimal, I can go to 1.2. I don't care which one you use here. Doesn't matter to me, they're all the same. Regardless, I have found the answer. All of these equations have exactly the same meaning, but the bottom one tells me what the variable is, and the top one hides it. They're all the same. They're all the same. Unlike the English language, you only have a few options sometimes to rephrase a sentence and still have it mean exactly the same thing. Your options are a little bit tricky, that as soon as you rephrase it too much, you could lose the meaning, right? But in this language, I rephrase a whole bunch of times, and the meaning is exactly the same. Exactly. I didn't lose anything, and I didn't gain anything either. So this technical language allows me to do things that I can't do in, I guess, conventional language. All right. So when I encounter an equation, I now know what to do with it, I hope. But when I look at my steps, where are those steps? Here. Here are the steps. That's not the first thing that is going to be an issue in a word problem. The first steps, looking at this, half the question, and the most important part of the question, setting me up for the rest, is to give names to the unknown numbers that I need to work with and to translate the information. Now, to practice this second step, this is where the main issue is, that if step 2 goes well, the rest will go well with a high probability. If step 2 doesn't go well, and it's wrong, then of course everything that follows that is wrong. So really the key focus is on this translation. Now to make that easier, we might only focus on half of the equation, or maybe just another side. We don't always have to make a full equation to practice this translation issue. Exercise 16.6 is a good first example. And as we do full word problems, we'll do the translation, of course, because it's one of the steps, right? But let's just try and isolate the main issue in this four-step process with something like exercise 16.6. A group of friends collect comic books. We call one side, when we don't have a full equation, we just have this maybe. We call that an algebraic expression. Algebraic because it has this variable in it. Expression or phrase, it's not a full sentence, right? It's not grammatically complete. It's just a little snippet of it. Algebraic expression. So that means it won't be an equation. Write that for each of the following in terms of the number C of comic books that Casey owns. So they were very nice in this case. They defined a variable for me. C is the number of comic books that Casey owns. Who is Casey? I don't know. I don't care. Doesn't matter. So I can skip step one because step one is done for me. And only in those cases can I skip step one. It's done already. You may introduce a new variable. We're not going to need to do that, but make it clear what they represent. We don't need to do that. So let me just start this. Do we have a new page? Yes, we do. Oh. Exercise 16.6. Now, even in this simple setting, people don't give this enough attention. And then when this exact same issue comes up in a full word problem, they don't know what to do. Let's build it up, even in these simple situations. Make sure we understand this translation happening. Okay, so C is the number of comic books that Casey owns. Number one, K has 3 times as many comic books as Casey. Now, because I don't have a full equation, I don't have a full mathematical sentence, and even when I do, I like to have some English words around it. So we can definitely mix our languages, totally fine. K has 3 times as many comic books. If Casey has C comic books, K has 3 times C comic books. And there is my algebraic expression. It can be merged into an English sentence. That's totally fine. It actually is nicer. It reads much more nicer, much more in a much more convenient way for anyone who may want to read it, because the mathematical language doesn't read as nicely in all situations with just it on its own. It's nice to have some English words around it. Makes us understand it better. Number 2, Nancy has twice as many comic books as Casey. Can we represent the number of books that Nancy has in terms of or using that variable C? They say twice as many, so Nancy has 2C books. So I have to use the variable available to me to represent a new, different quantity. Again, we start very simple because I don't know what your background and experience is. I don't want to assume anything. Number 3, Jinfa has only half as many comic books as Casey. Half as many. Jinfa has, now you could write a half times C, or you can write C over 2, or you can write 0.5 times C, I don't care. Do whatever makes you happy there. Because they're all equivalent. And I can represent the number of books using the existing variable. Doesn't matter to me which one of those you pick. Number 4, Fortuna has 4 more comic books than K has. 4 more comic books than K. So let me just start here with her name. 4 more than K. K has 3C, so I have to add 4 to that. And there is my algebraic expression. I think we have one more. Number 5, part of our introduction. Melissa has 2 fewer comic books than Fortuna has. So let's write our little sentence here. Melissa S has 2 fewer comic books than Fortuna. Fortuna has 3C plus 4. And then 2 fewer would be minus 2 books. I don't care about simplifying it. I don't care about any version here, as long as it is technically correct. If this comes up in a larger equation, yes, then in step 3, I want to simplify it. That's not a concern right now. I know people are obsessed with simplification because it happens somewhere in school. They make you seem like it's a super important thing. It's not. It's not. Same with the fractions. When we did fractions and we found something like 12 over 20, for example. I can't remember exactly. I don't simplify that. I don't care. There's nothing wrong with that fraction. Same here. Though if you want to write 3C plus 2, you're welcome to. This is exact same meaning. You just don't need to. So our first issue is to make sure we can do that translation. Especially, well, we do it first in isolation, in a simple setting so we can build on something. Because when it comes up in more difficult or more involved word problems, then I sort of neglect that translation portion, even though it is the heart of the whole solution process. And without it, I won't get the right answer. But with it, the rest is kind of formality. Okay, how's our time? Our time is good. Our time is good. All right, so we have exercise 16.7, which I'm not sure why it's different from the rest. It's just 2 problems. It's just 2 word problems. I'm not sure why they're grouped together. They're not related in any way. We'll just see what they say. Write an equation for each of the following using a variable and then solve it. Yeah, okay, so it's not even... I think they make it easier because they define a variable for me and the others don't, right? That's it. That's it, I think. Okay, so let's read number 1. Fannie's company has a mortgage debt of 120 million and Freddie's company has a debt of X million. So by saying it this way, they are defining X as the variable that represents Freddie's company's debt in millions of dollars. So I can skip step 1. Unless I have another variable I want, I don't need to do step 1. They've done it for me. Together, their debt is 560 million. What is the debt of Freddie's company? The value of X. Again, we start with something fairly straightforward, but not all of them will be easy for you. And it's hard to say which one is going to be tricky for you. Everyone's different. Everyone is different. So I want to give attention to each one as they come up. Sometimes it's going to be easy, sometimes not. So this one isn't step 1. It's, let's do it like this, I guess. Oops. Let's say 16.7.1. There we go. So I can, even though they tell me, I can remind myself what X represents. Because it's done for me, I don't have to redefine it. I can just do a reminder, and that doesn't have to be a full sentence. It's not going to be graded because X is already defined, right? X represents Freddie's debt in millions of dollars. Okay, I remember it because sometimes it gets lost in the sentence, in all the words. So it's nice to remind myself. But I didn't have to, it was done for me. Now I want to translate the information. And depending on the complexity of the situation, how much information there is, how convoluted it is in its presentation, I want to help myself here. You don't have to write the final equation as the only thing that you write here. Help yourself. Say to yourself, well, I'm going to have Fanny plus Freddie's debt, and that's going to give me the total. And I'm doing this for myself. Read it if you want to, but it's for me. It's not for you to read. It helps me. So I now have my equation here. I feel I'm ready now. It helped me. Fanny's debt is 120. Freddie's debt is X. And the total is 560. Now you can do unit symbols here. You can do dollar signs and whatever other units may come up later. But it's not really, it shouldn't be in your final product, in your final equation. You can use units on the way, but your equation, I don't feel, should have units. It looks a little sloppy. So that's my equation. Done. Put a box around it. Back it up. But they do say I should solve it. Okay. So I have step 3 to do as well. I might want to rewrite it so I don't mess up. Whoops, that's not a 2, it's an X. I don't mess up my nice equation in a box there. I want to subtract 120 on both sides. The equation is not complicated in this case, but it's very often a case of whatever this equation requires, that's what I'm going to do. And I'll get 440, right? So it didn't require much in this case. And then, of course, last step, I think is very important, but we can agree to disagree. I want to write what the answer is in the words of the question, because the answer isn't 440. The answer is $440 million, and that's not necessarily the same. So a nice sentence just clarifies that Freddie's company has a debt of 440 million. Now there's no doubt. This is my answer. I can double check even. Sometimes it's worth double checking before you write that concluding sentence. Double check. Is what I want to say actually answering the question? What is the debt of Freddie's company? Okay, it is. Good. I can move on. Just as a little final check. Because very quickly, we saw it last time in percentages. Sometimes the variable that I work with and calculate isn't quite the answer that the question wanted. I can get it very quickly from that variable, but I should check what is the question asking and can I answer that? They don't care about anything else. All right, so it's really just practicing these 4 steps, getting used to the process, thinking about it the right way so that when things get complicated, I'm able to rely on that base, that foundation, and build on that. We're going to do number 2, and that will be the end for today. Then you are welcome to work ahead if you like the challenge, but we'll just do all of these problems tomorrow. And maybe we'll finish them all, maybe we won't. We have lots of time. Okay. Number 2. I'll hide number one. Number one is over. The price of a ticket to Animal World is $32 per day. Tanya bought 1-day tickets to Animal World and to Air Park for herself and 4 of her friends for $300. What was the 1-day price per person at Air Park? Now, you can maybe guess and check your way through this, maybe. But it doesn't seem like a very efficient way to go. The numbers might not be very pleasant. Ticket price could be weird. It could have cents in it. I don't know. And guessing could take forever. So I don't want to do that. They, let me check, define a variable for me. They give me information, information, information. There is no variable defined for me. Okay, so I definitely have to do step one. Now, they ask, what was the 1-day price per person at Air Park? Well, they tell me the price to Animal World, right? So don't need to have a variable for that. It's 32. The price per person ticket at Air Park is what they want to know. So usually, not absolutely always, but for our level of question, almost always. The thing that they want to know is a good starting point for a variable. So let's do it. I want to write that down, right? Full sentence. I just need to pick a symbol. Now, usually it's something to remind me about what it means, but you could just go for a generic X or a generic Y or whatever. Doesn't matter. Let's mix it up and go for a Y. Because why not? That represents the 1-day per person ticket price to Air Park. Take the extra few seconds and be very clear in what your variable represents. I will say it on the record now. If you say y equals Air Park, I will not give you your mark that is reserved for step one because this is not clear. Maybe you know in your mind what you want to say and what the variable means, but if it doesn't come across on paper, virtual paper, it doesn't count. It's on record. If anyone complains, I will go to the timestamp of the video at this point and say, you were warned. It needs to be a sentence complete, completely clear in its meaning. Okay, now that we've settled that, let's move on. Now, hopefully that's enough to build my equation and my translation completely. But, in some cases, I see it in calculus all the time, that you might, as you're doing step two, it turns out, oh, there's another variable. And then you go up here and define it again. For our level, almost always, one variable should be sufficient, and I definitely want to try and get away with just one variable. But if it comes up that, oh, I didn't want to define the variable this way, go back, change it. Once you finish a step, it's not set in stone and done. You can go back, absolutely. Okay, so let me just read this again. Because reading a question once, a word problem, is not enough for me. I don't remember. By the time I get to the end, I don't remember the beginning at all. I need to read this as many times as I want, as I need to. I don't want to. I need to be clear on what to do. So I have Animal World tickets and Air Park tickets, and the total cost is $300. Okay, so let me get rid of this. So I'm going to make a plan, and my plan is, let's say here, Animal World cost plus Air Park cost will equal the total. Nice logic there. Not nice writing, but still. So you can look in the book. I'm not going to drag it back and forth all the time. The price for an Animal World ticket is $32 a day. 32 per day per person. Okay. I'm writing notes here for myself to get it out of the word problem, out of the sentences, and help myself. We decided that the air park ticket is going to cost Y dollars per day per person. Okay, that's just a reminder for me. I need it. I choose to write it. Okay, so now let's see. So Animal World costs $32 a day per person. Now everything is just happening on one day, so I don't really care about the day. Now she bought tickets for herself and four of her friends. So she bought 5 tickets. So Animal World is going to cost 5 times 32. Then she also bought tickets for the same number of people to Air Park. So that's going to be 5 times y. When it's a number and a variable, it doesn't need a times symbol. When it's two numbers, it needs a times symbol. Different rules. And then it's a total of $300. I can then go, because this is so important. I can go and scan. Did I understand this right? Okay, she bought one-day tickets to Animal World and Air Park for herself, four of her friends, so that's 5 people, $300. Okay, I think we're good. I think we're good. Double check, because everything you're doing now is going to rely on this equation. My equation's done. I move on with my life. Oh, but it's not simplified. I don't care. That is never a requirement in step 2. In step 3, it's a different story. Now I want to clean this up and figure out how to rewrite this so I get the value of y. So let's just show something in chat because it's been pretty quiet. I want to know what's 5 times 32. Is MathBot going to tell me? MathBot, if you take that long, I'm just going to do it in my head. 160 plus 5y equals 300. Now I look at this and I say, okay, I'm going to subtract 160 on both sides. That's my little scribble to help myself. So 5y, that does not look like 5. Come on. Doesn't look like anything else either, but let's make it as clear as possible. I'll have 140 left on the other side here, so I'm dividing by 5. Maybe you're not super comfortable with this. Use your calculator, it's all good. Let's show something in the chat. Doesn't matter. 140 divided by 5. Oopsie. Definitely be sure. And I get 28. That's done. That's step 3. It's over. Move on. Now I double check. Okay, I want to say what is the y, right? Y is the exact price to Air Park, one ticket price. Is that what I need to have as an answer? What is the one-day price per person at Air Park? Okay, perfect. So my variable value is exactly what the question wants. I just need to say it in complete English. Okay. The ticket, everything's one day, so I'll drop the one day. The ticket price to Air Park is $28. Done. Let's zoom out maybe. Zoom out a touch so I can see the whole thing here. No, random line. There we go. Start to finish. Nice. Systematic. I didn't care about the answer at step 1. I didn't care about the answer at step 2. I actually didn't care about the answer at step 3 either. It just came out to be whatever it is. I trust the system to guide me to the eventual answer, focusing on the step I'm doing when I am doing it. And the answer is going to come naturally. It can't not come. It's designed to get an answer at the end. but I never have to worry about it. All right, we are out of time. It's a good place to pause anyway, not stop. We obviously want to practice this more. There's 4 steps over and over and over and over. But from one word problem to the next, there's a lot of variety. And I can't go into a word problem thinking, oh, this is going to be easy or I'm going to do this. No, I'm going to have to let the word problem guide me to what the translation is, what the equation is, what variables to define. And that uh, experience that I need to build up is going to take some time. But luckily, we have time, so it's all good. All right, that is it for today. Are there any questions on this that you would like to ask at this time? All right, then we will pause here until tomorrow.